Good morning again, everybody. These are the answers to yesterday's problems. I sent them, or will be sending them as a PDF, so you can check your answers there as well. I didn't think it was too difficult. It was just using a calculator, getting used to second sine, second cosine, second tan, etc. So finding those. So now, how are we going to put all this together? Well, we're going to put all this together by solving a right triangle. To solve a right triangle means to find all unknown angles and side lengths. And you can do that when you know either of the following. Two different side lengths. Let me close that there, go back to that. Two side lengths, or one side length in the measure of one of the acute angles. What I find most helpful is to making a little table like this. I have put them into the problems for today, but you should probably do this as you're doing your own problems. Angle A, angle B, angle C. We're going to have three angles, three sides, A, B, and C. Now, how did I get these letters A, B, and C? If you notice, if angle A is here, right, I called the side opposite lowercase a. That's how our nomenclature usually goes in triangles. Angle A, the side opposite A, use lowercase a. It's still also side BC, but it just makes things a little easier when we're organizing the numbers we have. We're going to be able to fill these in with numbers, these with angles. We're always going to have one right angle. So we're always going to have one of these three angles that says 90 degrees across from angle B. Here's angle B. Opposite angle B is side B. And opposite angle C is side C. That's where I get A, B, and C. That's just a way to name the sides without having to use the two letters. It's still side AB, BC, and AC. So let's take a look at a problem, how this actually works. Solve the right triangle. Round decimal answers to the nearest tenth. So we have our little table, and we're going to start filling things in. We know where our right angle is. Our right angle is at C. So what is the measure of angle C? Measure of angle C is 90. So we put a 90 in there. We don't know these two angles, right? We don't know angle A, we don't know angle B. Unknown, unknown. What is the measure of side A? Well, side A is across from angle A. That's a 3. Side B is across from angle B. That's a 2. And we don't know C. That's our X. We can call these, like I had talked about before, theta and phi. That's a horrible phi, but you get the idea. So these are our unknowns, right? We don't know angle A and angle B, and we don't know side C. So let's work on this first. How do we find the third side if we know two sides in a right triangle? We're going to use the Pythagorean theorem. A squared plus B squared equals C squared. So, oh, wrong one, sorry. Let's go back to pen and thin. All right, so C squared equals A squared plus B squared, right? We've done this a number of times already. C squared, A squared is 3 squared equals 3 squared plus 2 squared. And I know my writing here is horrible on this, but please bear with me with this. So C squared is equal to 3 squared is 9, 2 squared is 4, 13, So c squared is equal to 13, but what does that make c? In order to get c, we're going to take the square root of both sides. The square root of c squared is just c, so c is the square root of 13. So we can go back over here to our table, right? That was just an example. And we're going to write in square root of 13. Now we have our three sides. How do we find these angles? Well, we can use sine, cosine, or tangent, right? That's what we did the past few days, so we know. Let's work with angle A first. Angle A. We can use any of the sides. I like using tangent only because it's opposite and adjacent. Opposite and adjacent, we know the 3 and 2. So the tangent of angle A is equal to opposite over adjacent. So angle A is equal to inverse tangent of 3 over 2. Do I have room? Yes, I do. Where would I go now? Well, to get angle A, I'm going to go to my calculator. Turn it on. That's stuff from yesterday. Make sure your mode is on degree mode. We need to be in degree mode in order to do this correctly. Well, so I'm going to hit the second button because I'm looking for the inverse tangent. Second tan of 3 divided by 2. Close parentheses. Enter. Nearest tenth will be 56.3 degrees. Whoa, don't know what happened there. 56.3 degrees. So the measure of angle A is 56.3 degrees. So I'll go back up here and fill that in. .3 degrees. So now that I know that, how do I get angle B? Do I have to go through this whole process again with a tangent or a sine or a cosine? I do not. The two acute angles in any right triangle, these two angles, there's our right angle, these two angles, always equal 90 degrees. Why? Because a triangle adds up to be 180. But if I know this is already 90, that leaves 90 for these two. So to get angle B, I'm going to subtract 56.3 from 90. Angle B is equal to 90 minus 56.3. Put that in our calculator. 90 minus 56.3 equals 33.7. So angle B is 33.7 degrees, and we have now solved the right triangle. Could we have used the tangent, sine, cosine, whichever? Of course we could. Do you want to verify that that's true? What would the tangent of angle B equal? Tangent is opposite over adjacent. So the tangent of angle B, let's just verify that to make sure. It's easier to do what I just did, but let's try. So the tangent of angle B is equal to 2 over 3. Yeah, that's supposed to be a 2, right? So what does angle B equal? Angle B equals tangent inverse of 2 over 3. And we'll go to our trusty calculator. Second tangent 2 divided by 3, close parentheses, and look what we get, 33.7 degrees. 33.7 degrees. So that's really all there is, ladies and gentlemen, to solving a right triangle. Let's try another one. I changed the letters here just to show that they can be anything. Doesn't matter. Here we have angle DEF. DEF. Opposite angle D would be side D. Opposite angle E would be side E. And opposite angle F would be side F. Actually, our hypotenuse. So the first thing we're going to do is, in this little table we know, fill in what we know. What do we know here? Well, we know that angle F is our right angle. So if angle F is our right angle, that's 90. We know that side E, opposite angle E, this little e here, is 20. And we know that side D is 21. How do we find this? Side F. To find side F, we're going to use the Pythagorean theorem. F squared equals E squared plus D squared. A squared plus B squared equals C squared. So, wow, this is horrible. 20 squared plus 21 squared equals 400 plus, what's 21 squared? Anyone know? If you don't, go to your calculator. 21 squared is 441. Equals 441 plus 400 is 841. That's our F squared. F is equal to the square root of 841. Now, set to round to the nearest 10th decimal answers. We could round this to the nearest 10th. I like leaving it as this, unless it's a perfect square. Let's just check. Make sure it's not. Second square root of 841. Oh, look, it is a perfect square. So I would not leave it as a square root of 841. I would put it in as 29. You can always check. So I know that F is 29. 29. Now I'm going to find angle D or angle E. Doesn't matter which one I find. I'm going to go for E, right above the 90. I'll use tangent again, only because I had those two numbers to begin with. So the tangent of angle E is equal to opposite over adjacent, which makes angle E equal to inverse tangent of 20 over 21. So angle E is equal to, where do we have to go? Back to our calculator. Second tangent, 20 divided by 21, close parentheses, enter, 43.6. So that's angle E. 43.6. And how would I now get angle D? Just subtract that from 90. 90 minus 43.6. Minus 43.6. Go to the calculator. 90 minus 43.6 is equal to 46.4. There you have it, ladies and gentlemen. We have solved the right triangle, rounding all our decimals to the nearest tenth. I have a few examples here. This is similar to what we just did. We have two sides. Find the third side using the Pythagorean theorem. Let me go to one. Here's one. Good. Here I have an angle and one side. This might be a little bit different. This might be a little bit harder to solve. I don't know. Let's see if we can find that out. Where's our right angle? Angle Z is 90. So let's put that in. 90 is right there. Only this time I know angle X is 52. And I know the length of Y is 8.5. How am I going to solve this one? Well, I can get angle Y right away. Angle Y is 90 minus 52. What is 90 minus 52? Should be 38, right? So I have angle Y right away because I have these two angles. Now I have to find X and Z. Where's X? X is over here. Z is over here. Does it matter which one I find first? No, it doesn't. But I have to use sine or cosine or tangent. Personally, I would continue to use tangent. What do we know? We have this angle. What is the tangent? The tangent of 52 tangent of 52 is equal to opposite over adjacent. When this x is in the numerator, we multiply. It's why we did all that other stuff leading up to this. So what does x equal? X equals 8.5 times the tangent of 52. That's just a number in the calculator. 8.5 tangent of 52. 10 point, round to the nearest tenth is 10.9. So x is 10.9. How do I now find z? I could use one of my trig functions again, but once I know the two sides of the triangle, I'm going to use the Pythagorean theorem. Z squared is equal to 10.9 squared plus 8.5 squared, which equals, let's go to the calculator, 10.9 squared button plus, what am I adding together? 8.5 squared. Enter. I get 191.06. But I need to take the square root of that. That's not my answer. That is z squared. To find z, I have to take the square root of 191.06 13.8 today's it looks like a weird number, but whatever. All right, 13.8. So I've now solved the triangle. I have the three angles and the three sides, everything to the nearest tenth. Here's another one. How would we do this? Well, in this one again, we know one angle and one side. So we're going to have to use the angle to find one of the other sides. We can use the angle to find the third angle easily enough. Identify our 90-degree angle first. That's here. J, so J is 90. H is 25. 90 minus 25, what does that give us? 65. So we found the angle right away. We know, what length do we know? We know the hypotenuse, which is opposite J, is 13. So we have to find H and G. We need one of our trig functions to find H or G, doesn't matter which, and then we can use the Pythagorean theorem to find the other side. So let's use tangent again. Sorry, we can't use tangent this time because we have a hypotenuse. So we're going to have to use either sine or cosine. Look at that. So which do you want to use? Let's just go with sine because that's first. So what is the sine of 25 equal to? The sine of 25 is equal to opposite over hypotenuse. H over 13, right? Opposite over hypotenuse. Just multiply by 13. H is equal to 13 sine 25. Go to your calculator. I'm going to clear everything out for now. 13 sine 25. Nearest tenth is 5.5. So H is equal to 5.5. How do I now find G? I could use the cosine, find G, but I think it's easier to use the Pythagorean theorem. 13 squared is equal to 5.5 squared plus g squared. 13 squared is, you know what 13 squared is? 169. 169 is equal to 5.5 squared $30.25 plus g squared. Subtract 30.25 and take the square root. 169 minus 30.25 equals, and remember, this is g squared, so we have to take the square root of that. 38.75. Enter. 11.8. G is 11.8. And we have solved the triangle for all the missing sides and angles. All right, sort of a word problem. The school is building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. Rake stage means a raised stage. You want the rake, the angle of elevation, to be 5 degrees or less for safety. Is the rake stage within your desired range? We're solving for this angle, right? What do we know? If we're at this angle, we have opposite and hypotenuse. What uses opposite and hypotenuse? Ooh, that silence was me waiting for you to say out loud in your house. Sine. So the sine of x is equal to 2 over 30. Now you don't have to reduce this because what does x equal? X equals inverse sine of 2 divided by 30. Go to the calculator. Second, sine 2 divided by 30, close parentheses, enter. That angle is 3.8 degrees. X equals 3.8 degrees. So the answer to the question, yes, it's within our desired range because it's supposed to be less than 5 degrees. 3.8 is less than 5 degrees. And I think we're good. Closure. A right triangle has legs of 8 and 13. Solve the triangle. I will leave that for you as well as your practice. You're going to do what you need to do as soon as you get a word problem like this is to draw the right triangle. I'll at least set it up for you. What does it look like? Right, there's a right triangle. There's the right angle. Horrible right angle, but we know that. Which ones are the legs? Right, legs. Legs. These are the legs. One is 8. One is 13. Call this whatever letters you want. The first thing you're going to find is the hypotenuse. Call it ABC, just for easy sake. Make a little chart and solve for this. I will give you the answers to that tomorrow as well. This will be your practice. 6 problems. They're here, but I'm sending this as a PDF as well, so you'll be able to see it. Hope you understood that, ladies and gentlemen. Have a great day. There will be another announcement coming today. Uh, just letting you know now, we're supposed to be live, quote unquote, with you guys, which does not mean video, but it does mean I need to be available to be live to you. So I think I found a way that I can do that and answer your questions where you can ask them to me, sort of like texting them to me. But we'll see how that works. Anyway, have a great day. Stay safe, stay well. I will talk to you tomorrow.